Blessed Man Meditations is where we provide answers to the intellectual side of Christianity and equip Christians to provide a defense for the hope that is in them. Today we continue our look at Is Atheism Dead by Eric Metaxas. Metaxas is a best-selling author. He's written for the New York Times, the New Yorker, the Atlantic, and the Wall Street Journal. Today we continue our look at part 1 of Is Atheism Dead by Eric Metaxas. Today is chapter 3, The Fine-Tuned Planet. The most famous atheist in the world was riding in the back of a car. Suddenly, someone from the front seat put a camera in his face and asked him which argument was the best from the other side, the theistic side, the side that argued for the existence of God. In the course of this fortune-gathering series of debates with rabbis, priests, ministers, lay believers, and imams, Christopher Hitchens had heard them all. He'd heard all the arguments for God's existence. So, Christopher Hitchens was going to answer the question, what was the best theistic argument? What was the best argument from the other side? What would Christopher Hitchens say? Could he admit that there was any argument on the other side that was worth dignifying? Hitchens was very rarely anything other than a forensics bully, never conceding a grain to the other side of the scale. Even when he knew the truth was otherwise, even when he knew there were good points the theists made. For him, the affair was less about finding the truth and humiliating his opponent at any cost, evidently believing the audience wouldn't know the difference. I have found this personally true in dealing with some atheists personally myself, atheists and agnostics myself, who they seem to want to humiliate you rather than really get to the bottom of things. They really don't have concern for what you have to say. I see that too in some of the comments that I receive from skeptics to some of these videos. They don't even listen to your whole presentation. They just attack you for what you believe. If they can humiliate you sufficiently, they can discourage you enough, they hope, so that you'll stop trying to get the word out there. But it so happened in this unique case, for reasons we may never know, that Hitchens answered quickly and honestly. Hitchens admitted that the best argument from the theistic side is the fine-tuned argument. The fine-tuning. That 1 degree, 1 hair of difference, even though it doesn't prove design, doesn't prove a designer, you have to spend time thinking about it, working on it, Hitchens admitted. It's not a trivial argument. We all say that, Hitchens said. Hitchens admitted, other atheists admit, that the fine-tuning argument is a good argument. This was a rather dramatic concession from the self-styled infant terrible turned snarly curmudgeon who generally conceded nothing, yet it gave comfort to the scoundrels who dared take the other side of the debate over whether God exists. When he said, we all say that, Hitchens, when he said, we all say that the fine-tuning argument's the best argument for the theistic side, Hitchens meant that the 3 others, Dawkins, Dennett, and Harris, who had become known as the 4 horsemen of the new atheism for their bitter spate of angry books and appearances in which they savaged religious people of all kinds, never bothering to distinguish between the Torquemada and the 9/11 hijackers on the one hand and St. Francis and Dietrich Bonhoeffer on the other. These celebrated opponents of the new atheism had heard many arguments against their view, but Hitchens said it was this one, the argument of a fine-tuned universe, that they had thought was the best. The 4 pictured below thought that the fine-tuned argument for the planet was the best. Hitchens was adamantly opposed to those backward religionists he loved to demonize as the embodiment of evil, although ostensibly he didn't believe in evil. No matter, it suited him at the moment. But for some reason, he seemed to let his cat out of the bag. The fact that he said his colleagues also felt this way is still more significant, because many of them have publicly averred the opposite, denouncing the argument as idiocy. So, in other words, Dawkins, Dennett, and Harris will say publicly that the fine-tuning argument's not very good, but privately, amongst themselves, According to Hitchens, they will say that the fine-tuned argument is apparently the best that the theists have, and it's a very good one. But here on camera, Hitchens made plain that all of them felt as he did. So, are we to believe that the new atheists aren't honest with us when they speak publicly and publicly denounce religions? Are we to believe Hitchens? We can't ask him anymore now. But are we to believe that they're not being honest? How could they not feel that the fine-tuned argument was the best? Anyone hearing this argument for the first time is knocked backwards by it, usually wondering how it could be that they hadn't heard it before. But what exactly is the fine-tuned argument? Well, Metaxas says it is simply that there are certain things about our universe, about our planet, that seem to be so extremely perfectly calibrated that they can hardly be coincidental. If these things were even slightly different, life would not even be possible. One classic example of the fine-tuned argument has to do with the size of the Earth, which just happens to be exactly what it needs to be in order for life to exist here. Of course, most of us can't imagine that the size of our planet would have any bearing on whether or not life could exist here, but as it happens, we're perfectly mistaken. It turns out the size of the Earth, among many other things, is essential for life to exist on our planet. One rarely hears about this, but it's an established fact. If our planet were smaller or larger, even by the smallest of margins, life here could not exist. When we see how many things must be just so, and then just happen to be just so, we cannot help but wonder if perhaps mere coincidence is not enough to account for this. Most of this fine-tuning also involves what's described as the Goldilocks principle, meaning that there are actually two directions in which things can go wrong. Or they can be just right, as Goldilocks deemed the bed and chair and bowl of porridge she settled on after rejecting the other choices. As with the story of the three bears, we find that on Earth and in this universe, things could be too this or too that, too hard or too soft, too big or too small, too hot or too cold. But in every case, it just so happens to be that they are just right for life. The size of our Earth is but one of innumerable and ever-increasing examples of this fine-tuning. That is what is especially remarkable about the fine-tuning argument. The more time passes, the stronger the fine-tuning argument gets, because science discovers more and more examples of fine-tuning. So it is one thing to say, as scientist Carl Sagan did, that there are two parameters necessary for life, and Earth just happens to meet both of them. It would be the same if there were 5 necessary parameters, or 10. We still might be able to see the Earth's having met these parameters as a matter of simple good luck. If just a couple of things were required, and just those couple of things were discovered, that might be just luck, or might just be coincidence. But it turns out that there are more than just a couple. As the decades have passed, science has uncovered more and more and more hundreds of such examples of perfect fine-tuning. So the odds, as they continue to discover these examples of perfect fine-tuning, the odds become more and more remote that random chance is behind the design, that random chance is behind the planet, that random chance is behind the universe. There's too much of it to dismiss it as luck or coincidence. The overwhelming impression is that the burgeoning welter of perfect coincidences is mounted to a level impossibly beyond anything we can put down to coincidence, so that even the most hostile atheist must at least wonder whether it's all precisely as it is precisely because it was intentionally designed to be that way. So Metaxas wonders, why haven't we heard this before? He says most people have never heard about any of this. He says there are 2 main reasons for that. The first reason that most of us have not heard about this is that it cuts against the narrative that the scientific establishment has been pushing with all its might, and has done so roughly since Darwin. The The fine-tuning argument is that the universe and the planet on which we all live did not come into existence by accident, but the universe and the planet were deliberately and intentionally created. This idea, like the discomforting idea of a universe with a beginning, is very embarrassing to anyone wed to a strictly materialistic account of things, because materialism is insufficient to explain the beginning of the universe. The materialism is insufficient to explain the fine-tuning. And as we say, it is the more embarrassing because the constant stream of scientific discoveries makes it stronger over time. Science continues to make discoveries, or science doesn't say anything, scientists do, as Frank Turk says. Science continues to discover things that continue to show that things like fine-tuning are true. And in this book, we're going to go through several things. That science is the principal engine driving this fine-tuning can come across as a particularly stinging irony for anyone wedded to that old atheistic narrative. And what a strange reversal of fortune it seems. Far from the idea that science and faith are enemies, or that science is increasingly pushing back any need we have for God, we discover that forward march of science is instead pushing back the argument against God. Science is continuing to make the theist's case. Science is continuing to make the case for theism, as opposed to atheism. It's just that the atheists are louder, and they're more voluminous than the theists.
Whoops, I meant to say vociferous, not voluminous.
And for the Christian who believes the Bible is the inspired word of God, we're not surprised by this. Because we know that the way, not that theism is in itself sufficient for eternal life, you need Christ for that, but we know that there are going to be more that don't believe than there will be that believe. There will be more unbelievers than believers. We're not surprised by this. The gospel is powerful. But there are fewer people who will be willing to submit to the lordship of Christ because people want to do their own thing. They don't want anyone telling them what to do. It is an upending of the idea that people of faith worship a God of the gaps who is increasingly irrelevant as science fills in those gaps. So, yeah, the repeated refrain of the atheistic crowd is that just science is the source of all knowledge. Things that we don't know yet, just give science more time and we'll get there. They can just keep saying that. They can just keep saying that because the things that we don't know, the things that we'll never know, maybe it's just because science hasn't been given long enough to know these things. There are some things that are outside the realm of what science can discover, and we've discussed that elsewhere and probably have or will in this book as well. On the contrary, as science progresses, we see that the God of the gaps is actually a creation of the atheists. And the creator God of the Bible is a God whose existence is increasingly bolstered by science. The idea that people of faith cling to God to avoid science has been replaced with the idea that atheists cling to their invented God of the gaps idea to avoid the real God who created the universe that science is discovering, and whose existence is increasingly undeniable because of those very discoveries. In a way, it seems that in flaunting this invented God of the gaps, atheists have projected their own insecurities onto people of faith and have used their God of the gaps idea as a crutch for themselves, who were too insecure and perhaps too prideful to accommodate the possibility of a real God whose existence is revealed by scientific discoveries. But another reason most of us have not heard the fine-tuned argument is simply that the evidence has been piling up incrementally over the decades, and there was never any single movement when it was suddenly known. The strength of the fine-tuned argument has grown quietly, but it has piled up so much in the last decades that some atheists have felt the need to address it, albeit without very much gusto, so that simply avoiding it is usually the preferred tack. So what is the fine-tuned argument? Once upon a time, it was possible to believe that life could exist anywhere in the universe, and we assumed that life probably existed on many planets. That's because we believed that the conditions for life were not difficult to meet. And since there were so many stars and so many planets, it only followed logically that there must be plenty of life out there. In fact, in the year Time published its famous cover story, the astronomer Carl Sagan said that there were only two criteria required for life to exist on any planet. One was having a star, something like our sun, and the other was being the right distance from that star. Since those two conditions were so easy to meet, there must be literally billions of planets in the universe that could support life. That used to be the thought. Given this now very primitive understanding of how easily life could emerge from non-life in such places, Carl Sagan confidently calculated that there should be innumerable planets with life. This kind of thinking, coupled with Star Trek on TV every week, led to the widespread idea that a colorful variety of life existed throughout the universe. And it was only a matter of time before we found it. Or only a matter of time before life found us. Not long after Sagan made his bold pronouncement, however, subsequent scientific discoveries made it increasingly untrue. And you see that today. Science is regularly changing course, doing a complete 180, thinking they were right about something and then changing their mind into the opposite conclusion about the very same topic. I just don't anticipate that science will do that about the origin of the universe, because changing from an atheistic worldview to a theistic worldview requires a humility, requires an accountability that they don't want to have to deal with. So the more science learned about the conditions necessary for life, the more science found new criteria that were just as vital as the two Sagan had mentioned. The two, again, were having a star and being the right distance from that star. Eventually there were dozens, and the more science learned, the more there were. More conditions necessary for life, requirements for life. So, of course, the probability of life in the universe plummeted drastically from billions of planets to probably having life down to... the probability of life in the universe plummeted drastically from billions of planets probably having life down to millions and then to thousands. Every time another condition was discovered that was necessary for life, it mathematically reduced the number of planets containing life down until the conditions mounted so high that the number of planets that support life was winnowed to almost nothing. And, of course, I would think that most thinking Christians would think that the only planet that is conducive to supporting life is planet Earth. I would think that's the case. I would hope that's the case. Eventually, the conditions of science reckoned necessary for life had risen so high that the idea that life existed anywhere at all, as it obviously did on our planet, seemed more and more miraculous and then even outlandish. It didn't make sense that we existed, and yet here we are. And what to make of it? It seemed that the only rational answer for our existence was that everything in the universe had been intentionally designed so that life here on Earth could exist. So that was the fine-tuned argument. Whenever folks like Hitchens bumped into it, they knew there was little they had to say against it. So they began to migrate toward far-fetched scenarios like the existence of an infinity of universes, the multiverse theory, despite there being no evidence for that. And that's that objection was also addressed in I Don't Have Enough Faith to Be an Atheist. I believe that they responded to the multiverse argument there as well. And that book's 20 years old. This is 2023. Saying, let's see, so atheists began to migrate toward the multiverse, despite there being no evidence for that. And that's the same thing they said, and I Don't Have Enough Faith to Be an Atheist, that there's no evidence for the multiverse, and saying that one of them probably just happened to have all the right conditions for life, and of course, by further happy coincidence, we just happen to be living in the universe that has all the right conditions for life. Lucky we. The unscientific nature of this idea seemed no barrier to embracing it, because the idea of a world fine-tuned by some creator was simply too unpleasant to consider, so that the new atheists had fled into the realm of pseudo-philosophy we call wishful thinking. As we have mentioned, evidence for extreme fine-tuning increases as science advances. The more time elapses, the more evidence for fine-tuning comes in. The fine-tuning argument's also often called the anthropic principle. I think that was a term that was used I don't have enough faith to be an atheist, the anthropic principle. And if you Google the anthropic principle, you'll get responses for evidences for it that way. But because it's called the anthropic principle because anthropos is a Greek word that means human being, and these strangely perfect calibrations create the perfect environment for human life. So as we talk about fine-tuning, we should clarify that there are two principal ways in which things appear to be fine-tuned. The first way things appear to be fine-tuned concerns the universe itself, meaning that everything emerged from nothing into something in the past 13.8 billion years ago. The second concerns our planet specifically, which came into being roughly 4.5 billion with a B years ago. So the first example of the fine-tuned planet concerns the size of the Earth. We've all grown up being exposed endlessly to science fiction TV programs and movies, assuming that life exists throughout the universe on all kinds of planets. So it never dawned on us that the size of our planet could have anything to do with whether or not life could exist on it. We might accept that a planet's size could affect what kind of life emerged, but how could the size of the planet affect the existence of life itself? As Metaxas mentioned earlier, in the 1960s and then through the ensuing decades through the magic of reruns, the actors William Shatner and Leonard Nimoy, in their guises as Captain James Tiberius Kirk and Mr. Spock, rocketed through the universe to a new planet each week, encountering various types of life, although most of them were curiously anthropomorphic. But the idea of life everywhere in the universe has been part of the zeitgeist of our time. Based on this idea, the search for extraterrestrial intelligence, the SETI project, was launched. I believe that was mentioned in I Don't Have Enough Faith to Be an Atheist. The SETI project was launched, scanning the universe for radio messages from distant civilizations. Nothing was ever found, no surprise there, but scientists kept trying. Of course, we now know that the premise was extremely optimistic, and as time passes, such efforts to find life on other planets come across as willful naivety, because we can now see that far too many things need to be just so for any planetary environment to be friendly for life. There has been, and maybe there still is, talk about life on Mars, or colonizing on Mars. I believe if we would have been able to do that, somebody with a lot of means to make that happen probably would have gone and tried. Maybe that's happened, I don't know. One of the simplest examples of this has to do with the size of our planet. The size of our planet is one of the things that makes it fine-tuned for life. We know that if our own Earth were any bigger or smaller, life here could not exist. This is only one of the parameters we've discovered is necessary for life, but the size of the Earth is a good place to begin. The first question must be why the size of our planet would have anything to do with whether life could flourish, and the first and simplest has to do with our magnetic field. Whoever thinks about the Earth's magnetic field? I don't. And who, listening to this video, who is not a scientist, thinks about the Earth's magnetic field? I would venture to guess most of us don't. But it happens nonetheless to be magnificently important in many ways. If the Earth were any smaller, our magnetic field would be weaker, and what we call the solar wind would quickly strip our atmosphere down to almost nothing, so that we would end up like Mars, which of course is a lifeless world. And who thinks about the solar wind? But if we did, we would realize that it is a stream of charged particles, ion gas or plasma, made up of electrons, protons, and some alpha rays blasted toward us every moment from the sun. But because of the size of our planet, our magnetosphere is just powerful enough to protect us from that radiation. The magnetospheres of the gigantic planets Jupiter and Saturn are also very powerful. And just as happens here on planet Earth, Their magnetospheres detect the solar wind so that it travels mostly around them instead of to their surfaces. Here on Earth, the solar winds would have long ago stripped away our hydrogen and oxygen, which of course make up water, which could hardly be more important. Water is essential for life. Mars is not much smaller than Earth, but it is just small enough that its magnetosphere cannot protect it, and as we have said, most of its atmosphere was stripped away eons ago. This is just one aspect of the fine-tuning of Earth's environment, illustrating how little it would take for life here to be impossible. But it's a fact that if the Earth were slightly smaller, there could be no life here. But if the Earth were any larger, we would have other life-killing problems. In their book, The Privileged Planet, authors Guillermo Gonzalez and Jay Richards explained that a larger Earth would have more powerful gravity so that no water or methane or carbon dioxide could escape our atmosphere, which would be so thick we couldn't breathe. Our air would be more viscous. According to Gonzalez and Richards, Earth may be almost as big as a terrestrial planet can get. Again, who would ever think that the size of our planet would be so precisely and perfectly calibrated for life, that if it were even slightly smaller or slightly larger, there could be no life whatsoever? But the more science learns, the more we see that science fiction scenarios we've grown up with are hopelessly out of date and confuse us into believing that conditions for life on any given planet can vary dramatically. But now we know that they cannot. Conditions for life cannot vary dramatically. We know now that conditions for life must be met very specifically. We venture into the sublime madness of water in a subsequent chapter, and if ever there was something we took for granted, water would be it. But before that, let's simply acknowledge the uncontroversial fact that water is inescapably central to life on Earth. But because of this, several things must also be very precisely just so. For example, if we were even slightly closer to the sun, most of our water would have evaporated and life couldn't exist. By the same token, if we were slightly further away, all water would have frozen, also making life untenable. As we've said, even Carl Sagan in 1966 knew that our distance from the sun was dispositive. It's one of the easier things for us to understand about fine-tuning. But whoever would have dreamt that the presence in our solar system of the so-called gas giants, Jupiter and Saturn, was just as crucial? After all, why should these colossally large and very distant planets have any bearing on whether life could exist here? And yet we now know that is the case. We know that having Jupiter and Saturn where they are is essential to having life here on Earth. And it's one more thing we didn't know back when Carl Sagan was making his overconfident predictions. It turns out that Jupiter and Saturn, like planetary linebackers, run interference for us. In other words, if they weren't where they are, our planets would be endlessly pelted with meteorites and asteroids. Perhaps 1,000 times as many would make it to our surface. Can any of us imagine spending our lives gazing upward in fear? Actually, we wouldn't ever have come into being, so it's a moot point. But now we know that it's only the tremendous mass and gravity of these two monstrously large planets that protects us, because they pull most of these speeding objects away from us, either by simply deflecting them out into space or actually absorbing them into themselves. So life here on Earth, without them, simply would not even be possible. Have you ever heard this before? And now that we know this is what science has taught us, we must wonder. Is it merely a happy coincidence that they're there? Or is it possible that our existence here was intended all along and these titanic planets were intentionally put where they are? In case anyone's not convinced that endless flights of asteroidal missiles hitting Earth would affect the conditions necessary for life, we should recall that the asteroid that hit Earth 66 million years ago, kicking up so much dust that our atmosphere didn't let in light for the longest time, killing much of plant life, not to mention 75% of all animal life on the planet, including all the dinosaurs. But imagine, that single asteroid was just 7 miles in diameter, and Earth is 8,000 miles in diameter. It's hard to think something so comparatively small could have such a far-reaching effect, but of course it did. So we can also imagine that if something like this were happening more often, life here would never have had any real chance of beginning at all, if asteroids kept hitting the Earth. We didn't understand until 1980 that it was the asteroid that killed off the dinosaurs, but once again, the more science reveals, the more extraordinary our existence seems. Since we are on that subject, we should also mention the 1908 Tunguska event, which an asteroid only 300 feet in diameter, inexpressibly tiny in comparison to our planet, exploded above an uninhabited region of Siberia. When it did, it instantly flattened 80 million trees. Wow. An asteroid that was only 300 feet wide destroyed 80 million trees and caused so much atmospheric disturbance that the effects were noticed as far as London. That's wild. Can we imagine if such things happened constantly? Life would not exist. We should try, because without Jupiter and Saturn, we know that it would be happening. We wouldn't be protected from the asteroids by Jupiter and Saturn. So it's a fact. If Jupiter and Saturn weren't there, we wouldn't be here. Next, let's look at the moon. Most of us don't think much about what the moon is doing where it is, or whether it might have any serious effect on life here. In fact, if it were a list of things if there were a list of things that we take most for granted, like the blue color of the sky or the air we breathe or the ubiquity of water, the moon would have to be near the top of the things that the moon would have to be near the top of the list of the things that we take for granted. After all, there it is, and always has been, quietly reflecting the sun's light and waxing and waning so wonderfully calendrically that we've used it to mark time forever, just as we've used our own orbit around the sun, and we've used Earth's own revolution around its axis to do the same. The Bible poetically calls the moon the silent witness in the sky. There it is, there it always has been. But who among us knows its presence is crucial to life on Earth? Or who among us knows how the moon got there? Science only recently came to where it finally understands how the moon came into being, and to see that all the details of its size and proximity to Earth are inescapably central to our existence. For example, we now know that if the moon were slightly larger or slightly smaller, life here on Earth could not exist. But before we go into that and other things, let's look at how the moon came into being. When Metaxas was growing up, no one knew how the moon had come into being. There were theories, but not until the 6 Apollo missions from 1969 to 1972 did we have enough facts to begin to grope our way toward an answer of how the moon came into being. Well, into the 1980s and beyond the 1980s, most of us had heard that the moon came to us from another distant galaxy. That is, it swept close to us. The gravity of Earth grabbed the moon, and it's been with us ever since. Another theory was that it was created when Earth was created, but neither is the case. It didn't. The gravity of Earth didn't grab it and bring it to us, and it wasn't created when the Earth was created. What actually happened, which we only know because of recent science, is undeniably more interesting and far more amazing than any previous theory. First of all, 4.5 billion years ago, the planet that eventually became Earth was very different from what it is now. To be accurate, it wasn't yet Earth. Most of us haven't heard about this before because it was only recently understood. But the planet that became Earth was actually smaller than Earth. It was a kind of proto-Earth that scientists usually refer to as Theia. But one day, a few million years after the formation of this proto-Earth, something happened. A Mars-sized object just happened to hit Theia at just the perfect angle and at just the perfect speed. The object that collided with the proto-Earth also had precisely the right composition. This all happened very shortly after the formation of the proto-Earth as part of the solar system. But we know that if it had not happened, and happened precisely as it happened in every detail, we would not be here. It's another inescapably amazing coincidence to consider. So what happened? As we've said, it was the mysteriously perfect collision of two planet-sized spheres hurtling through an infinity for millions and millions of years. Space is unimaginably vast, and the spaces between planets and stars are much greater than we can imagine. So it's not as if collisions between monumentally huge objects happen often. To say they do not is to say they do not happen often. To say that the collisions between monumentally huge objects happen often, they don't happen often. To say they don't happen often is an astronomical understatement. Planets and stars are usually so far away from each other that the whole galaxies can pass through each other with no collisions. So what happened when this Mars-sized sphere hit the proto-Earth was an exceedingly rare event. But more importantly, it was so precisely perfect in every way that the planet that emerged from the collision was extremely different from what it had been before as the smaller proto-Earth called Theia. And after the collision, it just happened to have everything necessary to support life. So we know that if the angle of the collision had been different, or if the speed of the collision had been different, we would not be here. There we go. another condition required for life. We also know that if the planet-sized object that collided with the planet that became Earth had been a different in size or composition, we would not be here. This is not science fiction. It's what science has rather recently come to understand. It seems miraculous, no matter what one's view of the situation is. But science is not in the business of proclaiming anything miraculous, even if something seems miraculous. I sense some sarcasm there from Metaxas, some tongue-in-cheek there from Metaxas. Science is simply in the business of finding out what happened. But science knows enough to say that if any details of what happened had been slightly different, we would not be here now. So what did happen? Many things did happen. First, as a result of this inconceivably powerful collision, the super thick atmosphere of the proto-Earth Theia exploded off into outer space, never to return. So the new planet, what we today call home, Earth, suddenly had a much thinner atmosphere. We know that the atmosphere on proto-Earth was 40 to 100 times denser than the atmosphere afterward. Breathing it would have been like trying to breathe in sand. So because of this extremely perfect collision, our planet instantly had a new atmosphere, one thin enough for sunlight to penetrate so the plants could grow, and thin enough for us to breathe as we are doing this very second. It's hard not to think that the whole thing was pre-planned because it's so strangely perfect, but all science can tell us is that it happened. Yes, so many perfect coincidences, as Metaxas likes to say, had to happen in order for life to exist. That for it to happen by randomness, it takes more faith to believe that than it takes to believe that there's a intelligent designer behind it all. As a result of this perfect collision, another entirely necessary thing happened. The Mars-sized object hit the proto-Earth so hard that most of the Mars-sized object actually became part of the proto-Earth, increasing the size of the proto-Earth to the size that Earth is today. But science knows that the mass that was added in this collision was absolutely crucial. For instance, as we've said, we were previously too small to have a magnetic field able to protect our atmosphere from the solar wind. The part of the Mars-sized object that did not become part of the new object we now call Earth exploded away into outer space and then congealed to form the moon. We can think of it as something like an unimaginably perfect billiard shot executed on a table light years in length. And the shot itself was so inconceivably powerful that the two similarly sized balls did not bounce off each other, but rather became part of each other, instantly creating a single larger ball, and ejecting enough mass to form a second ball about a quarter the size of the other. The larger one was, of course, Earth, and the smaller one, of course, was our moon. What could be stranger? Yet if it did not happen precisely as it did, science tells us that we would not be here. There's more that resulted from this collision that's also centrally important to the possibility of life on Earth. For example, the moon that emerged from this collision was precisely the size necessary for life to emerge and flourish on the newly formed Earth. To be clear, the size of our moon is outrageously large when compared with other moons in our solar system, but anything at all smaller would not have been sufficient to stabilize the wobble of our axis as it has done ever since and is doing now. But science tells us that the moon's stabilization of our axis is another unavoidable prerequisite for an environment where life could exist. For example, the moon's stabilization of our axis enables us to have just the right seasonal variation, with seasons mild enough that the temperature does not fluctuate wildly, which would make life impossible. So this perfect collision just happened to happen, and the size of the Earth and the size of the moon and the atmosphere and the axis of Earth were all magically and perfectly and suddenly established so that we could eventually live here now as we do. This perfect collision happened, and the size of the Earth, the size of the moon and the atmosphere and the axis of Earth all just happened by random chance to be what they are, to make life here possible. And all of that happened by random chance? That seems hard to swallow, that all those conditions could be as they were just by random chance. It seems to take more faith to believe that than it takes to believe that there is intelligent order and design behind it all. That there is providential control behind it all. But because it is only recently that science has settled on all this, most of us simply haven't heard about it. Now that we do know about it, however, we can add this breathtakingly perfect collision to the list of what appears to be outrageous coincidences. It's all really too far baffling to understate or to fully understand, but this is what science has come to know. Now we're going to look at a moon among moons. Now that we know how it was created, we can focus on the moon itself and the crucial role that the moon plays in enabling life on Earth. Let's first rehearse some basic lunar facts. For starters, our moon is extremely large compared to other moons in our solar system. Our moon is 27% the size of Earth, which is dramatically greater than the other relative size of other moons in our whole solar system. And precisely because of its size, as we've said, the moon has a vital steadying effect on our planet, making us wobble very little on our axis and giving us vitally stable climates. But our moon is so large that it also has enough gravity to cause our ocean's tides, which are also crucial to the ecosystems of our coasts, which are themselves vital to the rest of life on the planet. This is only the science of the matter, but we cannot be blamed for being astonished. For who among us has ever dreamt that the details of our moon could be absolutely crucial to life on Earth? To appreciate just how odd our moon is, we have to take a look at the other planets. But even before we talk about its size, the simple fact that we have only one moon is another striking anomaly. Again, this is likely something we assume as though it's merely normal, but it's very far from normal. Earth is the only planet in our entire solar system with one moon, and no other planet has one that can compare to the huge size of our moon, relatively speaking. There's nothing in our solar system to compare with it. For example, Mercury and Venus have no moons at all. Mars has 2 moons. Although they're comically tiny, it almost seems wrong to call them moons. Our moon's diameter is 2,000 miles, while Mars' 2 moons are 14 and 8 miles across, respectively. Then we come to the gigantic planets of Jupiter and Saturn, which have so many moons that we can literally no longer count them. Jupiter has roughly 79 moons in a tremendously wide variety of sizes, and at some point, they're so small we can't classify them as moons, so we stop counting. But even the largest of Jupiter's moons, Ganymede, is extremely tiny when compared to Jupiter. Jupiter's diameter is 11 times the diameter of Earth, so roughly 90,000 miles across. But Ganymede's just 3,000 miles across. So there's a picture of Ganymede below. So compared to even the largest moons in our solar system, ours is dramatically large. After Jupiter, there is a ringed Saturn with roughly 82 moons, then Uranus with 27 moons, then Neptune with 14 moons. Now is not the time to argue whether the next planet is a planet, but whatever Pluto is, we can settle on the fact that Pluto has no moons. So once again, nothing in our solar system can compare to our moon in its being singularly large, and also being singularly single, the only moon in Earth's orbit, which is of course why we simply call it the moon. Okay, like many things we're discussing, most of us haven't given eclipses very much thought. Eclipses happen. What of it? Who cares? Well, we're about to find out why we care. Previous generations did not take them so much for granted. Perhaps you've read the novels by Mark Twain or H. Rider Haggard, in which the sophisticated protagonist in a hostile land uses an almanac to predict the eclipse to astonish the natives who had been threatening violence. Perhaps you saw an episode of Gilligan's Island with the same plot, but did you know these fictional versions took the idea from an actual event in the year 1504? Christopher Columbus was that year stranded on an island that we now call Jamaica. The natives of Jamaica were gracious hosts, feeding Columbus and his crew, but 6 months discovered the limit of their hospitality. They would no longer part with their own food to help these strangers. Columbus realized his men would die of starvation. That's when the resourceful Genoan consulted an almanac, observing that a dramatic lunar eclipse would soon take place. So he warned the natives that if they stopped feeding his starving men, the moon would show its great anger with them. Of course, the lunar eclipse took place exactly as predicted, and Columbus' crew got their food and lived to tell the story. But as we've said, most of us either take eclipses mostly for granted, or at least are not appropriately stunned at how strange it is that they occur as they do. I'm speaking especially of what we call total eclipses, in which the moon comes between the sun and the earth, or the earth comes between the sun and the moon. These events are dramatically more amazing than most of us realize. As ever, one must know the facts for proper context and appreciation, so here they are. The distance from the Earth to the Sun is roughly 93 million miles. The distance from Earth to the Moon is roughly 240,000 miles. Therefore, the distance from the Earth to the Sun is almost exactly 400 times the distance from the Earth to the Moon. You can do the math and see, Metaxas says, but here is where it is genuinely mystifying. The diameter of the Sun is 865,370 miles, and the diameter of the Moon is 2,159 miles. If you do the math, you'll see this means the diameter of the Sun is almost exactly 400 times the diameter of the Moon. Interesting. Is that a mere coincidence? Because if this is true, and of course it is true because science tells us, it means that these two heavenly bodies will look precisely the same size to us here on Earth. Despite the staggering differences in our sizes from the vantage point of Earth, the Sun and the Moon appear to be the exact same size. And yet, this is so anomalous that it cannot be underscored enough, and yet most of us haven't given it a thought. We probably think, of course they look the same size. They're the Sun and the Moon. What other sizes should they be? They're all we've ever known, so we may be forgiven for not having noticed this astonishing phenomenon. But once you think about it, you realize it's impossibly strange that something so absolutely perfect would simply happen. But there's more to it. Only because of this extremely striking astronomical coincidence do we have total eclipses on Earth in which the disk of one covers the disk of the other nearly perfectly. Again, once one sees this, it's challenging not to scratch one's head. How is it that the Sun and Moon happen to fit over each other so very precisely during these eclipses? Why do they match up as though they were made to do that? When one knows the circumstances and details of all the other planets in our solar system, the whole thing seems even stranger. Nothing close to this happens on any other planet. So if one aspires to be a dedicatedly rational person, one can't help suspect that perhaps this isn't a mere coincidence. It just seems too perfect and too strange. But there it is. Who can help but wonder whether these things are not accidental or not coincidental? Can it be that this outlandish and happy oddity was actually intended, and just for us? Still, we might wonder, what exactly is the point of this celestial legerdemain? It seems there are a few reasons. For one thing, without eclipses, we could never know many things that we do know. Eclipses have made it possible to measure and understand things that would have been impossible to discover any other way. In The Privileged Planet, Guillermo Gonzalez and Jay Richards say that perfect solar eclipses are optimal for measuring a range of important phenomena such as the solar flash spectrum, prominences, starlight deflection, and Earth's rotation. Perhaps the most important thing about solar eclipses is that they have made it possible for us to know many things about our sun. Because our sun is so bright, we on Earth cannot see its edge or corona, which is Latin for crown, at all. We cannot see the sun's edge at all clearly, except during a solar eclipse. So, during eclipses, we've learned innumerable things, including how and when the sun throws up solar flares, which can change what is called space weather and can affect our satellite transmissions, which we obviously rely on more and more. Even more dramatic are what is called coronal mass ejections, which are so powerful they can blow out transformers right here on Earth. Without total solar eclipses, we could not have discovered them when we did. In 1868, while observing a solar eclipse in India, a French astronomer and an English physicist even discovered a new element. They saw it in the sun spectrum during the eclipse and named it helium, after Helios, the Greek name for the sun. It was not until 1895 that helium was discovered here on Earth. But the most famous example of an experiment involving an eclipse is when, in 1919, Sir Arthur Eddington observed that light from the sun was affected by gravity, just as Einstein predicted in his theory of relativity. This suddenly proved with direct observation what had been an extremely challenging and much doubted mathematical theory. Eddington proved something that had been previously doubted, but because of an eclipse, Einstein's theory was shown to be correct. Eddington proved Einstein's theory, but the relative sizes of the sun and moon as seen by us on Earth, touch the issue of symmetry and beauty. Just as with many things in nature, the aforementioned blue of the sky and the staggering panoply of creation, for example, certain phenomena seem to affect us in a way that points beyond simple scientific facts. The existence of the sun and moon seems to point to something ineffable, even before we know extraordinary how extraordinary it is that they appear to us to be the same size. How a sun and moon appear to be the same size when they're most definitely not is amazing. What is it in each of us that finds them beautiful? And what exactly is beauty? Can it be that they were put there in part for us to marvel at, to draw us out of ourselves as we gaze at them and contemplate our lives and place in the universe? That's another story. Before we move from this chapter on the fine-tuning of Earth to our next chapter, which will be the fine-tuning of the entire universe, we should touch on what lies between them, because the very placement of Earth within the universe is an example of fine-tuning. This is probably even harder for us to comprehend than the idea that Jupiter and Saturn's existence is crucial to our existence. But even the position of our solar system within our galaxy, the Milky Way, is vital to the existence of life here on Earth. Our solar system is located on the inner edge of the Orion arm of our galaxy, about 26,000 light years from the center. Science now understands that this is crucial to life on Earth in several ways. If we were closer to the galaxy's center, the radiation hitting us would be far greater because there are many more stars in the galaxy's center than out here on the spiral arms where we exist. So at the center, there are more active galactic nucleus outbursts, as well as more supernova and more gamma ray bursts. That would make life here impossible. We would also be far more likely to be hit by comets, which are more numerous. Gonzalez and Richards call where we are in our solar system the galactic habitable zone, meaning that it is the ideal location for a planet like ours to form and support life. But if we were further out from the center, there would be other problems. Stars farther out are orbited by planets significantly smaller than the Earth, so as we said, that would mean no atmosphere capable of supporting life. Neither would they be able to sustain plate tectonics, which is another element absolutely crucial to life as we know it, that we will touch on in Chapter 5. The authors even say that our galaxy is better suited for life than 98% of the other galaxies near us. That must be Gonzalez and Richards in the privileged planet. For one thing, it is shaped like a spiral. Stars in elliptical galaxies have less ordered orbits, like bees flying around a hive, so they're more likely to visit the galaxy's dangerous central regions. They're also more likely to pass through interstellar clouds at disastrously high speeds. So in many ways, our galaxy, a late-type metal-rich spiral galaxy with orderly orbits and comparatively little danger between spiral arms, just happens to be the rare galaxy perfectly suited for life, and our placement within that galaxy also happens to be perfectly suited for life. What should we make of any of this? Science now tells us that all of these varied parameters are not merely helpful to life on Earth, but are inescapably necessary for it. Can we face that our existence looks like nothing less than a mathematical impossibility? It is as though the more clearly we see these things, the more difficult they are to take in. Well, that is the conclusion of Chapter 3 of Is Atheism Dead by Eric Metaxas. Next time, we will look at Chapter 4 and see how the universe is fine-tuned for life. So, thank you for tuning in. Please like, comment, and subscribe. Please consider supporting this ministry by the purchase of the public work Pinnacles and Plateaus Meditations with the Psalmist. Please subscribe and be on the lookout for more on this book and some of the others that you'll see that I've posted. I've gone through I Don't Have Enough Faith to Be an Atheist by Frank Turek and Norm Geisler. Gone through the evidence for the resurrection from The Evidence That Demands a Verdict by Josh McDowell. I've gone through Is God a Moral Monster by Paul Copan, where he looks at several Old Testament texts that new atheists point to for why a good God cannot exist. Copan gives capable responses to those objections. And there's some fresh stuff that's in the works. So thank you for tuning in, and I hope you have a blessed rest of your day.